Hello and welcome to Maths by SAS. This is my third lesson of PTB 9th class science book, and exercise is 3.2 and this lesson is about logarithms. In this class, students, we will be learning and discussing how to find the numbers whose common logarithms are given. So please watch and understand this lesson carefully. The first situation is that we have to find the number whose common logarithm is 3.5621. Try to understand the question that here we have to find the number whose log is given. This value which is given to us is the value of, it's a log of some number. We have to find the original number. As we have to find the original number, so what we are going to do is we have to suppose, let the number be x, the number be x equals to x, and then what we are given with, that this is the log given. So what we have to do is log of 3.5621. Now recall that log of any number consists of two parts. One is the characteristic part and other one is the mantissa part. So it means that characteristic of this number, characteristic is the 3 and mantissa (0.5621). This is the mantissa which is given to us, and we have to find the number whose log is this. So what we are going to do, in order to get the number, we will be writing x equals to antilog of 3.5621. Watch the lesson carefully, that what is the role of characteristic and what is the role of mantissa in antilog questions. So first of all, what I have to do, I have to find the value of 56.56 in the antilog table. So let me keep my book under the camera so that I can show my students that how to locate 0.56. okay, 0.56. So what we can do is that this is the antilog table. First of all, reach in the column of 0.56, and 0.56 has to be located first in the column of 2, and that is giving me 3648, and then I have to move in the mean difference column 1, which is giving me 1. So when I will be adding 0.5621, and okay, when I will be adding 1 to 0.56, when is located in the column of 2, giving me 3648, and then I have to check the mean difference column 1, that is giving me 1. So this becomes 3649. Okay, and now what is the role of characteristic? So in order to mark the decimal in the number, what we have to do, we have to add 1 to the characteristic, and whatever answer is coming, we have to leave as many digits from your left hand side, and you have to put the decimal. Like characteristic here is 3, so when I will be adding 3 to when I will be adding 1 to that will become 4. So it means I have to leave how many digits? 4 digits from the left hand side, and I have to place a decimal. So the number for which the log is 3.5621 is 3649. I hope you are clear about this question, and let's move to the next question. And again, the next question is 1 bar point, let me see the question carefully. that 1 bar 0.7427. Again, we have to suppose, let the number be x. Number be x, and then log of x. This is log of x given. Log of x given to us is 1 bar 0.7427, and x, which is the requirement of question, anti-log 1 bar 0.7427. As this is the information about the log, so log of any number consists of two parts: characteristic, this one 1 bar, and mantissa is 0.7427. Again, I have to go in the anti-log table, and I have to locate 0.74 in the column of 2. 0.74 in the column of 2 gives me 5521, 5521, 5521, and then I have to look in the mean difference column of 7. Mean difference column of 7 is giving me 9. So let me add them up: 10, 3, 5, 5. 5530, 5530. Okay, so this is the number that we are getting. Let me perfect this calculation: 5521 plus 9. This gives me 5530. Now what we have to do in order to decide the number that we are going to put the decimal after how many digits, what is the role of characteristic, that we have to leave, we have to add 1 to the characteristic, and when I'm adding 1 to the characteristic, my answer comes 0. So a decimal has to be placed after how many digits in this calculation. That means that there has to be no 0 between this number and the decimal. So the value of x, or the number for which the log is given 1 bar 0.7427, is 0.5530. So I hope you are really clear that how we are deciding the role and use of characteristic when the log question is given, how characteristic is helping us in replacing the decimal in the question. I hope you are clear about this, and let's move to question number 4. And let me first read the question from the book carefully. Question 4 says, what replacement of the unknown in each of the following will make the statement true? Okay, so if we look at the question is given in logarithmic form, and I have to turn this question in exponential form first. So in order to turn this in the exponential form, what I will be doing, log 81 to the base 3 equals to L, or 81 equals to 3 raised to power of L. And now here we have the prime base, and here we have the composite base. Make the prime factors, okay, and try to create the same base on both sides. So 3 2s are, and 3 7s are 21, 3 9s are, and 3 3s are, and 3 1s are. For 81, I can write 3 how many times? 3 raised to power of 4 equals to 3 raised to power of L. Now the bases are same, so we can equate the power, because bases are same, so we can equate power. So L equals to 4, we can equate the power. Exponents will be equal. You must have to support your working with statements, otherwise examiner will not be giving you full marks. Moving to the second part, again the question is log 6 to the base a equals to 0.5. First of all, what we have to do, we have to turn the logarithmic equation into exponential form. 6 equals to a raised to power of 0.5. Now 0.5 can be written as how? I have to remove the decimal 0.5. It will become 5 by 10, and 5 by 10 can be reduced to 5 ones are and 5 twos are 1 by 2. So 6 equals to a raised to power 1 by 2. Now I need to find value of a, but a has power 1 by 2 on at the top. So what I will be doing, I have to take the reverse process, that I have to take the square. This is a raised to power 1 by 2 dot 2 multiplication sign. This goes, and 6 square is 36. So a equals to 6. So a is 36. Okay, and which is the required answer. Okay, moving to the next part, and the third part is that log n to the base 5. N to the base 5 is equal to 2. Again, turn your logarithmic equation into exponential. N equals to 5 square. Very easy, one step question only. N equals to 5 square is 25. Okay, and moving to the next question, that is 10 raised to power of p equals to 40. Okay, now what to do is that we have to turn this is exponential form given, and we have to turn it into the logarithmic form. So what I will be doing, that I will be taking log on both sides. Log 10 raised to power of p equals to log 40, or p equals to log 40. And now I hope you are clear that what we have to do, we have to find the log of 40. Log will have two parts, characteristic and mantissa, and characteristic of this number. This time I am not going with the scientific notation, I will be going by observation. It has 2 digits in the integral part. So what I will be doing, that characteristic is one number less than the number of digits. So characteristic will be 1, and mantissa. For mantissa calculation, I have to write this number nearest to 4 significant figures, and I have to check 40 in the column of 0, and that gives me 0.6021. So P will be equal to 1.6021. Really easy question, and it was different question. So let's have a look again, that in these all questions the logarithmic equations were given, but here exponential is given, the variable is in the power, so turn it into the logarithmic form. P will come down, and log 10 to the base 10 is 1, and log 40 we learned how to take log of any number in question number 1. You can take the help. If you find any difficulty in explanation and understanding, I will be giving the link of the lesson in the description box. Take help from there. Question number 6 says that, let me read the question first from the book. Question 6 says that find the value of x from the following statements, and first part is log x to the base 2 equals to 5. Very easy questions. Here the question is given in what form? In logarithmic form. Turn it into exponential form. X will be equal to 2 raised to power 5. This is exponential form, and x equals to 2 raised to power 5 means 2 to the 4 to the 8 to the 16 to the 32. And the next one is log 9 to the base 81 equals to x. Again turn into exponential. Okay, 81 raised to power of x. Now look, 81 is a composite number. Here we have the base 9. So 81, many times I have to multiply 9. 9 2 times, 9 square x. Okay, for convenience I can put 1 here. Otherwise no need. 9 raised to power 2x. Same basis. Base same. Base same. Okay, 1 equals to 2x, or x equals to 1 by 2. We can equate the powers. Okay, we can equate the powers. Powers equal. I hope one simple rule that we are applying on these all questions is that if the equation is in logarithmic form, turn it into exponential form. Then see the if we have some composite number, make the prime factors, and try to create same base on both sides. And if powers are unknown, when the bases will become same, powers will be equated, and if the powers are same, then the bases can be equated. I hope you are really clear about these all lessons of 3.2. Question 6 says find the value of x in each of the following statements. The equations which are given to us are in logarithmic form, and simple rule that we have to apply is that we have to turn logarithmic equations to what form? The exponential form. The first question is log 8 to the base 64 equals to x by 2. So first turn it into exponential form, that 8 equals to 64 raised to power of x by 2. Now look, 64 can be expressed as the powers of 8. 8 is how many times 64? When I multiply 8 by 8, 8 square raised to power of x by 2 equals to 8. No need to put index 1, it's understood, but for the convenience of my students, this time I'm putting 8 raised to power of 1, but later I will not be, if the index will be 1. Okay, now look, now this goes with this, 8 equals to 8 raised to power of x. Now you can see same base same, exponents can be equated. So 1 equals to x or x equals to 1, exponents can be equated, are equal. You must have to support your working with small statements so that examiner can understand your message easily. And moving to the next part is log 64 to the base x equals to 2. Log, how to read this? 64 to the base x equals to 2. Again logarithmic equation, and we have to turn it in exponential form. So what will this become? That 64 equals to x square. Okay, now look, here the unknown is, in the previous question the unknown was power, but here the base is a unknown. Here the base is a unknown. Okay, now and the index is 2. So what we have to do, in order to find value of this unknown, we have to think about some number whose power 2 can give me 64 back. Again 8 square equals to x square. And now look, now powers are same, exponents are same, or equal. So what we can do is we can equate the bases. 8 equals to x or x equals to 8. Bases are equal. This is the rule that we are applying. Really easy questions. And moving to the last part of today's class, that log x to the base 3 is equal to 4. Again turn it into exponential form. Okay, x equals to 3 raised to power of 4. Log x to the base 3 is equal to 4, and x will be equal to 3 raised to power of 4. X to the base a equals to 4. Log x to the base a equals to y, and we are using this rule on these all questions, that x will be equal to a raised to power of y. Now 3 raised to power of 4 means that I have to multiply 3 again and again. How many times? 4 times. 3 3s are 9, 3s are 27, 3s are 81. So the required value of x is 81. I hope you are really clear that how, when the logarithmic equations are given, we are using the relationship that log x to the base a equals to y, and when exponential form is given, we are turning it into the logarithmic form. One of the important concepts of your Lahore board examination. So please watch, understand this lesson properly. Please watch my lessons, like, share and subscribe the channel, and press bell icon to get a notification of every lesson in time. Thank you very much.